So we got trapezoid rule. It's going to be some equation. This case is x squared plus x between -1 and 3. Now the equation I could give you doesn't necessarily need to be anti-derived because we're doing a approximation with trapezoids. So when we do the approximation of trapezoids, it's 1 over the base times your first height. So your height here would be at -1 plus 2 times your middle height. So your height at 0. Your height as, oh, I'm sorry, it's b over 2. Yeah. I'm thinking of quadratics or something. B over 2. Again. Over here, height at 1, 2, height at 2. And you get to your final height, it'll be just a single, so height of 3. You can also write as f of x of 1, f of x of 2, f of x of 3. If you do anything else outside setting, you'll see it like that too. Okay, so now why did I pick -1, 0, 1, 2, 3? It's because that's the perfect gaps that make 4 equal sides. If it was a bigger range and I needed more pieces, you have to make sure you do that correctly. But on the test, because you're doing it by hand, really no calculator than like a 4 function, they're going to be easier numbers to deal with. So at worst, it would be a half, but most likely it would be whole numbers. That I see. You can technically get one from the front office. Yeah, so no, because piece 1, piece 2, piece 3, piece 4. You could graph and draw it out. That's fine, but it's not necessary.
I'm so sorry. Is this the example for the trapezoid problem?
What else would it be? I'm sorry, Matt. That was rude. This is the general formula here, but with the numbers plugged in already. So I start at -1, then I go 0, 1, 2, 3. But the general formula is wherever you start to wherever you end. So if I said 0 to 4, it'll be 0, 1, 2, 3, 4. If I said 6 to 10, 6, 7, 8, 9, 10. Say that again?
Oh, so the x's would be what?
Your heights at that point. How do you find the height at that point? You're going to plug it into the equation over here that gives you the height or where it is on the curve. So for h -1, I'm plugging into here. I'll do this one in red. -1 squared plus -1. Yeah. Then the next one, it's going to be 2 times h of 0. That's a little easy because it's 2 times 0 squared plus 0. Next one, 2 times, if I plug in 1 into the equation. So 1 squared plus 1. Two times, if I plug in 2 to the equation. 2 squared plus 2. Orange. And then the last one, because it's the end point, the end, you only do one of them. So no doubling it. So it's just 3 squared plus 3. And this is all going to be times by the base length divided by 2. Now the base length is how much the distance is from one height to the other. So from -1 to 0 or 0 to 1, that's a distance of 1. So it's just 1 over 2 on the outside. Yeah, big parenthesis. From there, it's a simple crunching numbers. 1/2 1/2. This is 1 minus 1, so that's 0, plus 0, plus 2 times 2 is 4, plus 4 plus 2 is 6, 6 times 2 is 12, plus 9 plus 3 is also 12. Oh, because you doubled this one. All right. One half of 24, 28. I'm sorry, times 28. That equals 14. So your area, an average, the approximation, I'm sorry, of the area is 14. If you have any questions, please ask. If not, I'll leave it up there so people can copy. I see people still working. Thanks. No problem.
That's already.
We got one more. We got to do the slope field. Or I'll just remind you of the slope field. But slope field at least is very simple, straightforward.
It's really only one more page.
Yeah.
If you want to go that page.
All right. Kaplan, you got to make up from the last time. What is an integral?
An integral. Like I don't know what it is. I just know how to do it.
Okay, an integral is, somebody help?
Variable and slope.
No. Say it again. It is an antiderivative. The area under the curve. An integral finds the area of the curve. Okay. I thought you said the slope. That's a derivative.
They're under like a line.
I got you.
Any line works.
Fair enough. So let's make points here. We'll make a 2 by 2. Or I guess technically it's a 5 by 5 and whatever. On the test, you'll get this printed out. You don't have to actually draw this. Okay. So slope field, when you get a slope field question, you're given a dy dx. And remember, a dy dx is the derivative, and a derivative is a slope at any given point. But we don't know where this equation actually starts, the original equation. So we could get an estimation of how it looks like with a slope field. So I'll just pick, let's do y plus x. Is that ironic, or is that sarcastic, or you think
No,
they're
no,
awesome?
I'm serious. I like that.
Yeah, it's simple, a little relaxing even, like painting basically. You know?
I love that.
Okay,
Remember my lab test? I
Oh.
have
what's up?
more relaxing.
But there's a lot of math in painting sometimes, golden ratios and all those kind of things. All right, so from here, you're just basically plugging in points and then graphing a slope appropriate to what point you got. So for example, if I start at 0, 0, if I plug in 0 plus 0 in this equation, my overall slope is 0. So it's gonna be flat like this. If I plugged in 0, 1, that'd be 0 plus 1, 1. So it'll be a positive slope kind of like this. 0 plus 2, that'd be a positive 2. So a little bit sharper. Again, I'm not really grading on the sharpness of it, but if this is like was negative, let's say, I'll be like, okay, you made a mistake. This should not be negative, it should be positive. So you just start plugging in numbers. If you have a negative situation, let's say like -1, 0, you should be going downwards, left to right downwards. If you have a positive, it should be left to right upwards. If it's 0, it should be flat. And then if you have an undefined, and the only way you could get an undefined, if you have a 0 in the denominator, that would equal, so like x over 0, let's say, that would equal a vertical line. So if you have 0 in the denominator, that'll be a vertical line. Okay, everyone try to fill out this slope field. The other type of problem is I give you a slope field and you match it to an equation. Because I can't really make that up on the spot, I'm just going to refer to look at the worksheet, okay? So I can't really make that up for this review, but And this right now is, I think, every type of question you have in your test. But tomorrow we'll have your, well, plus the yesterday stuff. So if I'm gonna make the test and then I'll get it approved. If there's something I missed, I'll add that to Fridays. Or no, we don't meet Friday, do we? Do we meet Friday? What's evens? Is it evens or odds?
I think it's odds.
It's odds? Okay, we meet Friday. If not, if we don't meet Friday, I'll just post it in the classroom. Hey, this, okay. Well, it'll be based off what we got approved on, so. Okay. That's true. I don't see my time. So -1 and 1.
That follows like a diagonal pattern.
Yes.
What is the x over 0 equal, what does that say?
If you have something like, I'll give you an example, like x equals y, and you plugged in a y equals 0, let's say, right? That would be undefined, and undefined is a vertical line.
Okay.
Really sharp. And these are going to be, there should be the surfaces. And if you start seeing patterns to your slope field, use that to your advantage. Like it kind of has a diagonal pattern, right? You have this diagonal line of flat lines at x equals -y, basically. You have these flat lines all the way through here. Then here's all positive lines. There's sharper positive lines. So you kind of have like this diagonal pattern going on, which is pretty interesting. You can use that to your advantage. And again, the matching, I'm not going to make up a problem for that. It doesn't really work. So just use the worksheet for those.
How many more tests we have?
So after pass over, what is it? It's a bunch of yolks, right? And then, what's up?
So this one, so 2 more to this one.
Probably one more. If I could fit 2 more, I could.
We have a retake last test.
No.
Can you give us like one more actual one? Yeah, like, oh my god, an optional one.
An optional. The optional one is your final.
No, it will only help us, we don't want to do final.
Yeah, that's why it's optional. You
No,
either
that's
could
not
have the
what it
option to
is.
take it or not.
What's the final one? It's on everything?
It has to be. We didn't have a midterm.
So nice. No, it's so nice. I'm not studying for that. It's not fair.
That's the cost of not having a midterm.
I just
Your
like
final
one
supercharge.
test, Still, I'm walking the
Yes, after derivatives, like the first chapter I can see like is not really associated, but limits built to derivatives, which built to antiderivatives. So
Well,
You
not
make
even
us
all
say, like,
limits.
what's the limit? Like, you're losing your derivative.
what's up?
You make us like find the there and slope.
You will not find a limit the long way with that h plus 0 thing. You never have to do that. Unless I form that as some kind of multiple choice question, like which one does this match? Maybe that kind of version, but you don't have to think about that. All right, I'm gonna stop recording because basically my review's done. You guys pull out your homework. Do any homework? Do you have leftovers?